this speech is focused on another aspect of my research. In the last presentation we see the topology optimization applied to architecture, and now in this work I want to try topology optimization and optimization in generally to industrial design, because my research team is oriented on architecture and industrial design. So usually this presentation is used in different conferences. Most of part of you have seen this project, so the structure that supports the roof is developed by the use of topology optimization. And so the research area of this topic is the environment sustainability and the setting. So I propose to investigate the relationship between structural optimization and material optimization from the eco-design point of view, because this kind of software, new software, are able to manage complex material like ply, and so it's very interesting to introduce, for example, recycled plastic. So we are trying to define innovative design methodology strongly oriented to material saving and monitoring shape, structure, and recycled materials. And we can integrate the structural optimization principles and rapid prototyping technologies in the first stage of the design process. So you need to operate a technological transfer from the mechanical engineering to the industrial design. So the designers using this methodology can work on products structurally efficient and transform concept to reality from their sketch saving times. An important point is also the prototyping phase, because as you can see in the picture and in the structure this complex structure is very complex. So I need a new technology, a new generation of rapid prototyping machine to produce the piece. So the tools of the method of the research is to investigate the potential of already known theoretical tools, a methodology development and experimentation and validation, in particular focus on integration of the CAD, CAA, CAM process. I presented in an Agro-Innovation Master course in my university some lessons, so the guys want to know more about structural optimization. So we worked on shared models, and starting from existing products, we apply topology optimization, and we get some interesting results, some organic results that you can see in the picture. Why we use existing products? Because existing products are already comfortable, are already tested with standards. So we can operate in a small field of application. The first example is a solution creating collaboration of an eco-designer. The name is Vadori. So we generate a family of results, not only directly to one result. We get a family of results, and then we apply the design phase. So here the designer worked on some suggestion that came out from the optimization. And the result is this chair called a chair, and it looks like very interesting. So we get I hope that the video didn't work, but no problem. We try to see. Sorry. Okay. This is the result of the share. In the other animation you can see the transition between the full model to the model with the holes. And this is the first experiment. The second experiment, called V-chair, is something different. So we start from this different assumption. In the first case, we have a starting model that is present on the market. But now I want to investigate, to exploit the optimization potential. So we started from a root model, that is the model on the left. It's a very simple model, and we get this kind of result. So for me, it's very unexpected results, and it shows exactly the type of the loads that are put on the structure. So we modeled this design space using a parametric modeler, so we can transform quickly the dimension of the chair, and we get a construction history. So we can move from the previous point, from the previous chair, to generate another chair quickly. We don't have to delete the surface and redesign the structure and then create new surfaces. It's a very quick way to produce model. Then we have to set up the model for the optimization analysis. So we create a load combination, a very simple load combination, because I want to investigate the potential. So like unleash the optimization in this case study. So we put on the chair load cases that simulate the weight on the seat. So the interior load is distributed in this way. 80% in this direction, 20% in this direction. And obviously on the legs are present the constraints. Then we run the analysis. So this is a snippet from the output file to know something. So I used a normal processor, a normal CPU speed, and a normal amount of memory. And the calculation required 12 minutes. So this was developed in 2008. Now we have more powerful laptops, so probably we need 6 minutes to recalculate the structure.